we come to our keynote speaker, Peter Stone. Okay, well, nice to meet you, Peter. We haven't actually formally met, so now we know you can hear me. Okay, so it is my distinct pleasure to welcome our keynote speaker, Dr. Peter Stone, who is a renowned American computer scientist. He's also the David Button Jr. Centennial Professor of Computer Science at the University of Texas at Austin, and he is a leading expert in machine learning, multi-agent systems, and robotics. He received his doctoral degree in 1998, following a master's degree 3 years earlier, both from Carnegie Mellon University, where he spent another year as a postdoctoral fellow. He spent a few years at AT&T Labs before joining the computer science department at the University of Texas at Austin as an assistant professor in 2002. He became full professor in 2012. Since his graduation, he has co-authored over 700 journal and conference papers. Peter has made significant contributions to the field of AI, with a particular focus on creating complete intelligent agents that possess crucial capabilities, such as adaptation, interaction, and embodiment. His research spans various cutting-edge applications, including robot soccer, autonomous bidding agents, autonomous vehicles, autonomic computing, and social agents. During his 25-year career, he garnered several awards and has been recognized for his outstanding contributions to the field. I'll just mention two. In 2007, he received the I.J. Kai Computers and Thought Award, given once every 2 years to an outstanding AI researcher under 35. In 2012, he became a fellow of the Association for the Advancement of Artificial Intelligence. He actually was a signatory to the letter that's made the rounds, which discussed the idea of having a 6-month moratorium on advanced artificial intelligence research. There's a lot of pros and cons about AI research, and this shows his commitment to safe AI research. So I would like everybody to welcome Peter Stone to this conference.
It's good to meet you too, and it's fantastic to be here virtually. I'm sorry I'm not able to be there in person and get my T-shirt for jogging later in the day, but it's great to be here. And I'm going to share my screen, and I was invited to give this presentation about sort of a big picture of artificial intelligence. And so I'm going to tell you mainly about a study that I've been deeply involved in over the past almost decade, called the 100-Year Study on AI 100. But before I do that, I'm going to tell a little bit about my own research, where I'm coming from. And since you brought it up in the introduction, I will also refer to the letter. In fact, I'll start by there. There was, I think it's been in the news, this letter on sort of the idea of a pause on a particular type of AI research, and it's not exactly. I wouldn't phrase it exactly the way that you did, Gordon. So you said a pause on advanced AI research, and I think actually that's not exactly what the letter says, nor what I would agree with. I actually didn't write the letter myself, and there's some of the rhetoric in it that I don't identify with. But there are. It specifically calls for a pause on the development of AI systems more powerful than GPT-4. Which is just a very, very specific type of AI research. And in fact, one of the things I'm going to cover in this talk is that artificial intelligence is much, much broader than large language models. And in fact, I think it's actually important that we accelerate research on AI in general and on studying the impacts of these large language models. The letter did cause for a pause on the development that would be verifiable worldwide, which I actually think is not practically feasible. So I think the main for impact from my perspective is that there will, that would raise awareness and accelerate research on the responses that the society needs to take to these models from the perspective of the impact they can have on our social, economic, and political systems, thinking about regulations, IP, all the kinds of things that these bring up for us that are, really we haven't had enough time to respond to. And so I hope that, and as well as talks like this one, and hopefully, also exposure to things like the 100-year study will cause people around the world and people in this room to really, accelerate our understanding of artificial intelligence and the things that it can do. And in my mind, I wouldn't be doing what I'm doing if I didn't believe that the world can very much be a much better place as a result of advances in artificial intelligence. And I'm really excited about what the future is going to bring. That being said, I am coming from the University of Texas. I'm sitting in Austin, Texas right now. And there's some really exciting times here. I'm a part of some cross-cutting organizations on campus. I am the associate chair of the Department of Computer Science right now. And since it was mentioned in some of the opening remarks, you have a master's in data science. I'll say our computer science department has recently launched an online master's in computer science, another one in data science. And just this fall, we're launching an online master's in artificial intelligence. And it's, I think the first in the country. It's got a price point of $10,000, and we've had huge interest. And I think these programs like your masters in data science and some of the few others that are popping up around the country are really critical, because one of the things that this country needs, this world needs, is more people who are literate in artificial intelligence, who can not only satisfy the demand of the workplace, but also help our policymakers and government leaders. I think this is a really crucial need that our universities, like Florida State, like UT Austin, are helping to fill. But I'm a part of we founded a new machine learning laboratory on the heels of being awarded one of the first National Science Foundation's AI institutes a couple of years ago, the Institute for the Foundations of Machine Learning. I'm also a founding member of a cross-cutting organization on our campus called Good Systems, which is our sort of AI for Good initiative. And this involves people. It was founded by our vice president of research and brings together people not only from computer science and engineering, but also from public policy, the School of Architecture, people who work in smart cities, philosophy, communications, really trying to evaluate what does it mean for an AI system to be good for society. What are the best practices for building such good systems? And I think this is a really important dimension of education and research in artificial intelligence these days. And then I'm a leader of an organization on campus called Texas Robotics, another cross-cutting organization. We have a beautiful new space. I hope some of you will come to see it. This is the gymnasium floor. We have sort of 4 basketball courts worth of open space that are now filled with robots. This was before we moved in, and we have. When I joined the university 20 years ago, we had 2 roboticists, and now we have 14 robotics faculty who publish in the top robotics conferences. So, but as Gordon said in the introduction, I have been working in artificial intelligence now for 30 years, since far before it was as cool as it is now. And in some sense, again, as mentioned in the opening remarks, AI is in its infancy. On the other hand, the field of AI has been around for about 70 years now. Still, as a discipline, that's quite young. But it's many people sort of think that it's this brand new effort that sort of popped onto the world scene with ChatGPT. But that's it's really as I think most of you in this room know, it's something that's been the long effort of many people over many years, and it's been sort of gradually improving. I think big impact of ChatGPT is just the breadth of access and how it went viral, and how people in all areas have been able to interact with it, and so that's been really game changing in many ways. But the technology has been growing over time. So to introduce, before I dive into the 100-year study, I'll give a one-slide introduction to my own research. And I do actually a lot of different things in my lab. The question that unifies all of them, and as Gordon said, it's in the introduction, sort of complete autonomous agents. It's the way I like to phrase it. It's to what degree can autonomous intelligent agents learn in the presence of teammates and or adversaries in real-time dynamic domains. So there's, as I said, AI is a very broad discipline. And so the sub areas of AI where I and my research group tend to publish are the ones listed here, the research on or conferences on autonomous agents, robotics, machine learning, especially reinforcement learning, and also multi-agent systems. And in my lab, we both develop new algorithms and analyses, sort of theoretical understandings of what can be done with artificial intelligence that I sort of call bottom-up research. And then we also do a bunch of use-inspired or problem-driven research, which I think of as more top-down research. And when I give a one-slide introduction, it's a lot easier to cover those, the top-down things, the kinds of applications that do drive my that drive the research in my lab. And so just a sampling of those. I have been involved in the and a leader in the annual robot soccer competitions, or RoboCup. So this is from more than 15 years ago, some of the old Sony Aibo robots playing soccer, where they have to sense, decide, and act together on a soccer field. When Sony stopped making those, RoboCup moved to these Aldebaran humanoid robots. So our robots in this video are the ones with their hands behind their backs. Again, fully autonomous, so they have to sense, decide, and act. Here you have a team of them, and working together. The goal of RoboCup is very ambitious. It's by the year 2050 to create a team of humanoid robots that can beat the best World Cup soccer team on a real soccer field. You can see we're a little bit far away from that in this video, but here you see our robot going in on a breakaway in the finals of a competition several years ago that we ended up winning against a team from the University of Bremen. And so here you see our robot calmly walking up to the ball and banking it off the goalpost and in. So we ended up winning this game 4-2. And when we came back to the University of Texas, they lit the tower orange for us, which they usually only do when the football team wins. So we were very excited about that. We have a similar football culture here at UT as you do at Florida State. So you'll be familiar with that. But robot soccer it's a very inspiring domain for research. Like I say, there's annual robot soccer competitions. The one coming up is in Bordeaux, France this July. And for those of you looking for sort of an entry to the field, and there's a lot of really great research challenges there. Now, RoboCup isn't just about soccer. There's also other robot competitions. One is called RoboCup at Home, where people work on robots to try to do what we sort of tasks in a house or a sort of an office building, what we call general purpose service robots. And if you come to my lab at UT, you'll see a robot like this one wandering around the hallways. You won't have to ask us for a demo. We try to have it on all the time in sort of our research on long-term autonomy. This particular video was research with my colleague Ray Mooney on grounded language learning, where we had the robot learning from human dialogue how to understand language, and this was before the large language models hit the scene. But we use these robots not just for natural language interaction, but also research on multi-robot navigation, on social navigation. Can the robots move through crowds of people between classes? Can two robots like this one pass each other through in the hallways? Can they do activity recognition? We have some with arms that work on things like helping people put away groceries or loading the dishwasher. So I call this sort of research on general purpose service robots. And then I've also, like many people in the field, been very inspired by the challenge of autonomous driving. And so this is a picture of my car that entered the DARPA Urban Challenge back in 2007. We don't have this car anymore because many of the car companies are investing very heavily in autonomous driving. But we still think a lot about what will the world look like when all the cars on the road are autonomous. Will we still need traffic signals and stop signs, or will we have systems that can be more efficient and look a little bit like this? And this is a video we put out of a simulation 20 years ago now. And what's going on here is the cars in white have called ahead to a program at the intersection, not a traffic signal. but it's sort of something that replaces it. And the ones that are white have already called ahead and gotten a reservation in space-time through the intersection that doesn't conflict with any other reservations. So the ones that are yellow don't have a reservation yet, so they have to stop before going through the intersection. But once they turn white, they have a guaranteed path through the intersection that won't collide with any other cars. And this has led to a decade of research on, for instance, what happens if there's autonomous cars mixed with human drivers, or we scale this up to multiple intersections and other ways of using multi-agent systems concepts to try to improve the traffic flow on our roads. And then most recently, which I'll take just a couple slides to talk about, my team at Sony AI, I'm also executive director of Sony AI America, we introduced an agent called GT Sophie, with a team of folks shown here. All of this research is collaborative, but here, this was a particularly large team where we had our research featured on the cover of Nature a little more than a year ago, the February 10th, 2022 issue, where we created an autonomous agent, one shown here in yellow, to play a game called Gran Turismo, which is a high-speed, very realistic high-speed racing game, and competed against the very best human drivers at this game. And so it's sort of, I see this as being one of in the stream of results such as Deep Blue beating Gary Kasparov and AlphaGo beating Lee Sedol, and the results in Jeopardy and poker. This was the first one on sort of a high-speed control task, where the AI agent needs to act in real time, both on an empty track is one thing, just the control problem, but also the tactical and multi-agent interactions. And and just like all those past ones that I sort of alluded to, this was right at the edge of where we could take a lot of data, a lot of top-notch engineering, a whole bunch of compute architecture, and then a few algorithmic innovations that appear in the paper, that are the methodological insights that really took us over the top. And like I say, this was no. I wasn't actually sure we'd be able to do this when we set out to do it. There are real human experts who've put in their 10,000 hours to be great at this driving task. Some of them go on after training in this simulator to join the real Formula One circuit. And the physics in this are really they model the airflow and slipstream and tire friction. And just to give you a sense of it, this is sort of what these what it looks like if you haven't played Gran Turismo, which I hadn't before we started this. It is a very they call it a real simulator because it's it does sort of model human race car driving. I'm not going to go into the details of this. I'll just say that we had the main event we had was in 2021. We raced 4 of the top drivers in the world. This was in the middle of COVID, so we were restricted to the top drivers in Japan, but they also happen to be the top drivers in the world, some of them, and raced them once in July and lost, but then again in October of 2021 and handily beat the best human drivers. And so that's what was featured. The article reporting on that was featured in the cover of Nature. And then just last month, or 2 months ago now, it was released into the video game Gran Turismo, and hundreds of thousands of people around the world were able to race against our AI agent, which I believe is one of the largest commercial deployments of reinforcement learning ever. So that's the sort of introduction to where I'm coming from, and sort of as a result of my long involvement in research in artificial intelligence, I had the opportunity several years ago to become involved in the 100-year study on artificial intelligence. And so I'm going to spend the rest of this time, telling you a little bit about that, and then also hopefully allowing plenty of time for discussion and questions. But in case you haven't heard of this, it's something I really encourage you to look into after this. It's a privately funded effort. It was started by a donation from Eric Horvitz and his wife Mary Horvitz. Eric is a luminary in the field of artificial intelligence and the head of research at Microsoft. It was launched in fall of 2014. And it's really designed to be a long-term investigation of artificial intelligence and its influences on people, and their communities and society with sort of reports every 5 years. And back in 2014, that seemed like a really good pace, of sort of reflecting on changes in artificial intelligence. And of course, things have really accelerated since then. And so now people, we're thinking, should we really be issuing reports more frequently? But it's, the goal was to try to envision possible future advances and to describe the technical and societal challenges and opportunities. The first report was written in 2016, and I was the first author of that report. So I'm going to briefly tell you about the 2016 report. And then the second report was issued a couple of years ago in 2021. And I was not formally an author of that report, but instead I was the chair of the standing committee that commissioned that report. And I'll tell you what that means in just a second. But I think it's despite being almost ancient history now, 2 years ago in the field of AI, it's actually I think still many of the conclusions are still very, very relevant. And so I'll tell you a little bit about that as we and hopefully again lead to questions and discussion. So first, I'll jump to a few slides from the first report. And again, I was the study panel chair on this. And we titled it "Artificial Intelligence and Life in 2030." The goal of the 100-year study as a whole is to support longitudinal study of influence of AI advances on people and society. It's supposed to sort of think about the trends and also futures and disruptions, and also comment on proactive efforts. It was sort of it launched with a 2008 study that happened in the Asilomar with leading experts from the artificial intelligence community. That was sort of where the idea was hatched. That was when Eric Horvitz was president of AAAI. And now the basic structure is that there's a standing committee that persists over time. And then every 5 years, it impanels a study panel. And so for the 2016 report, which was commissioned in 2015, I was the chair of the study panel. So I was the sort of bright red dot in this diagram in 2015. And then, the study panel dissolves after issuing the report. But then since then, I became the chair of the standing committee. So I guess I would be the bright blue dot if there were a bright one here. And my term is about to end actually in 2 weeks, and it'll be taken over by Vince Conitzer, but I'll remain on the standing committee for some time. But when I was chair, we did commission the second study panel, and that was when Michael Littman, who's now on leave at NSF, but he was the chair of that. And that's what I'll spend most of the time talking about today. The charge that the standing committee gave to my study panel back in 2015 was the following. It was to identify possible advances in AI over the next 15 years and their potential influences on daily life. So it was sort of scoped to look ahead 15 years to specify the scientific, engineering, and legal efforts that needed to be realized, to consider how to shape outcomes for good, and what kind of ethical and policy challenges would come up. And we were given sort of a focusing device to focus on large urban regions, like a typical North American city, or a first world city in any case is the way we took it. And that would allow us to think sort of the potential influences on a wide variety of activities and the interdependencies among them. And the main, one thing I want to just, have you take away from the 100-year study is to know that it's written in such a way to be hopefully useful and accessible to AI researchers, to the general public, to people in industry, and to policymakers. So really, everybody in this room should be able to get something out of this report. And it was, it's written in a very accessible way. And I've been told that people coming from outside the field do find it useful, and it's been used in AI classes as a way of getting students to sort of think of, introduce them to sort of the breadth of artificial intelligence. It's housed at Stanford University. That's where the endowment is housed, but it's really an independent organization of AI experts. And importantly, both the standing committee and the study panels have included people not just from computer science and engineering, but also people studying artificial intelligence from a humanities perspective and a social science perspective. And so this is just a sampling of some of the people who are on. Those were the people who were on the first study panel. And just to the structure of it, there is a very brief executive summary, an overview, an introduction that defines AI. And then also the main structure of that 2016 report was to look at 8 areas with likely urban impact by the year 2030. And it looks in each of those backwards 15 years and said what's changed, and also forwards 15 years and then calls out the opportunities, barriers, and realistic risks. Not the science fiction risks, but the realistic risks and the realistic possible benefits. And I was one of the students in my class who we used this on ran a sentiment analysis on it, and it came out almost balanced, leaning slightly positive, which is sort of roughly where we wanted it to be. We didn't want it to be all positive, all rosy picture of AI, also not an AI doomer document, but really to sort of give the balanced view. It also makes some policy and legal recommendations. That talks about the current status and makes recommendations. Again, very accessible. I encourage you to take a look at it. The areas of focus in the study panel, I'm not going to go into them in detail because I'm going to switch to the more recent report. But we looked at sort of transportation, home and service robots, healthcare, education, public safety and security, low resource communities, employment and workplace, and entertainment. And again, since we were charged with looking 15 years ahead, we're definitely within the still time horizon of that charge. And I think most of what we've written there is still very relevant. I'll switch. The last thing I'll just talk about is that we do define. It's been notoriously slippery to define what is artificial intelligence. The way we define it in that first study panel report is that artificial intelligence is a science and a set of computational technologies that are inspired by, but typically operate quite differently from, the ways people use their nervous systems and bodies to sense, learn, reason, and take action. And so notice, we don't define artificial intelligence as large language models or as neural networks, or, there's no commitment to what methods are used. It's a very broad view of what artificial intelligence is. And I think that's one of the biggest takeaways and lessons that I think it's really important to keep educating people about, that artificial intelligence is not one thing. There's reinforcement learning, natural language processing, vision planning, all of these kinds of areas fall under artificial intelligence. And so, it's not the sort of thing that you can just take and sprinkle on every application and, make it better. If you have a Go playing agent that can beat the human champion, that doesn't mean you can just take the technology and you put it into a robot to help you fold laundry. Every application is going to require sort of different methods, different kinds of techniques, and deep study. And so, we try not to talk about the influence of, or the properties of, quote, artificial intelligence, but rather properties of individual artificial intelligence. We don't talk about, quote, artificial intelligence, but rather artificial intelligence technologies, which are, broad and different. And that's part of the recommendation in that report, is that from a regulation perspective, we can't regulate artificial intelligence as a whole, but rather need to think about regulating and creating policies for artificial intelligence as used in transportation, or as used in healthcare, or maybe even more focused to that, as used in radiology, or used in patient care, things like that. So with that, I'll shift back to that's sort of a quick overview of the 2016 report. The idea of this is to persist over time. It's called the 100-year study, but it's actually endowed to go on for really indefinitely. And so the ambition is that every 5 years there will be reports issued. And the challenge of the second one in 2021 was to sort of set a precedent for what's going to come next. And the analogy we were using is, one point didn't really make a line. It was sort of a stake in the ground, but the second point does make a line and would sort of stake out a trajectory for what we saw this would be. So that was the challenge for the second study panel. Again, I was not on the study panel. I invited Michael Littman to chair it, and then worked with him to impanel the people. And these are, again, cross-disciplinary, but uniformly experts in artificial intelligence. And the charge that we, the standing committee, gave to this second study panel was to sort of try to create a template for future reports. And so we wanted them to do, to give some reflections on the field, to do deep dives in a couple of areas, and then to really make the heart of the report coming up with a set of questions that could be re-examined every 5 years. And so they took this and ran with it and created a series of standing questions. So questions that, again, could be re-examined in the next report, and we'll see if this is what the study panel in 2026 takes up. And so I'm just going to give you a list of these questions. There were about 12 of them, and what the conclusions on one slide per question, and then I'll be ready to open up for discussion. So the first question was just a fun one. It was, what are some examples of pictures that reflect important progress in AI and its influences? So it was, the way we thought of this was, what are pictures that could not have been taken 5 years ago, but could be taken today as a result of progress in artificial intelligence? And so there'll be one of those per slide moving forwards. And so for instance, on this one, an output from DALL-E, which didn't exist in 2016, but did in 2021. And so the first question is just, very high level. What are the most important advances in AI? And, even 2 years ago, generative adversarial networks, transformer language models, this was before everyone knew about ChatGPT, but it was already clear in 2021 or 2020, as this was being written, that this was one of the most important advances in the field. The robotic deliveries during the pandemic and expansions of AI systems into hospitals were sort of called out as some of the, and again, these are just highlights. If you go to the report, there's about 3 to 4 pages of text per question here. Again, written in a very accessible language that I hope you'll find very useful, but also going into technical depth for those of you who are well seasoned in the area. The next question was, what are the most inspiring open grand challenge problems, as in what's not solved? And I was gratified that they called out robot soccer or RoboCup as one of the challenges. There's been steady progress there, but still, there's still the robots are still not as good as people. They put a picture of me playing against the robots into the report, but there's others. That calls out some other existing research challenges, like trying to make AI generalize well, not just do individual tasks, to understand causal factors and to pick up cultural norms. The fourth question was, how much have we progressed in understanding the key mysteries of human intelligence? And the conclusion there was not a lot. That there's still a lot of work to be done in the sort of related field of neuroscience. There's a lot of intelligence that arises from interactions between brain regions, and also cooperation between groups of people. But really, there's still a lot to be learned. It's still a frontier of science. How does human intelligence work? People always talk about how neural network models are difficult to explain, and talk about explainable AI, but really, compared to the human brain, neural networks are quite accessible. We can go in and we can inspect them. We can do counterfactuals. There are ways of probing them that we're not able to do, with sort of crude fMRI machines and things like that we need to try to understand the way the human brain works. So there's a lot of excitement or a lot of challenges still on this question. The fifth question was, what are the prospects for more general artificial intelligence? And interestingly, the study panel's conclusion was that that human level AI systems feel further away than they did 5 years ago. Now, obviously not because the progress has reversed, but rather just that we understand more about what the difficulties are. Now, I'm not sure if that there's, I think that's even in the context of large language models, which they knew about and had access to. I think for many people, ChatGPT is saying, "Oh my," look, and GPT-4 is saying, "Look at how human-like these are." On the other hand, people studying them and looking at their limitations do uncover the sort of the weaknesses, and I think we're getting more and more sort of appreciation in the field about what can be done with just scaling data and computation, but also what can't be done. And so there is, certainly surprising progress that none of us would have predicted 5 years ago. Certainly those of us, the authors of the 2016 report, would not have predicted that there's, that the capabilities of ChatGPT would exist in 2023. On the other hand, they still do uncover what are the sort of unique properties of human level AI that are not still exhibited in these systems. And as you can see, they were aware of GPT-3, just not ChatGPT when they wrote the report. So the technology was close to what it is today. This is the question: how has public sentiment towards AI evolved, and how should we inform and educate the public? It talks a lot about media, and this is just an ongoing issue. It always has been in artificial intelligence. Is that there's always exaggerations of both in media and in sort of science fiction and popular culture that exaggerates both the positives and the negative of AI. And that's one of the main roles of this AI 100 study, is to try to be more balanced. And the conclusions here is that there have been some legitimate awareness raised, but the researchers and practitioners, we all need to keep these conversations going and keep the conversations grounded in reality. The seventh question was: how should governments act to ensure AI is developed and used responsibly? It calls out sort of the growing countries that are creating AI task forces. The level of policymakers, their sophistication has gone up significantly, but I think really there's still a big need for AI literacy in the government. They need evidence-based processes to innovate. And I think, again, this is the role for master's programs and like the ones that you're running and that we're running here at UT Austin, to help provide more people who will be able to have that interest in helping bring expertise deeply into government and policy. This is a very interesting and tricky one. What should the roles of academia and industry be, respectively, in the development and deployment of AI technologies and the study of impacts of AI? And this is something that also has really changed during my career. There's always been industrial presence of artificial intelligence research. I started my career at AT&T Labs, an offshoot of Bell Labs. There've been really good progress in industry. And there's been other places like Xerox PARC in the past, and NASA Ames and SRI, and there's usually some places where AI research is happening, but really in the past decade, there's been a lot more an uptick. That's what these graphs show: the rise in industrial affiliations on research papers. And this does raise a concern. It's fantastic in many ways. We would not have ChatGPT without the industrial research that's happening. On the other hand, we have to recognize that industry research labs are not necessarily driven by the needs of society as a whole, and so the question of what to study and how to disseminate knowledge is perhaps different than would be made if these developments were happening in academia, in the public sphere. And so the conclusion here was that this is something that's very important to keep an eye on. And there have been calls recently for sort of public investment in the compute and data needed to replicate, and create open source versions of these large language models, which is something that I think would be a very valuable development. The ninth question was: what are the most promising opportunities for artificial intelligence? The conclusion here was from the study panel, and this aligns very much with the one that I chaired in 2016, was that AI technology that researchers should focus on ways AI technology can better be integrated to work with people effectively. And I think I definitely think this is a way we shouldn't be thinking of jobs being replaced. That it's either a person doing a job or an artificial intelligence program doing a job, but rather we should be thinking about how can artificial intelligence technologies augment people's abilities, and how will jobs be transformed? How can they work with people to make to create decision making and executing entities that are better than people would be alone, and also better than AI programs would be alone. And then the last standing question was, what are the most pressing dangers of artificial intelligence? And again, trying to be grounded in reality and not, I think neither of our reports, neither the 2016 report nor the 2021 spent any real, significant time on sort of existential crisis or the worries of AI destroying the world or anything like that. That's not a near-term concern for the study panelists. On the other hand, there are pressing and real concerns of artificial intelligence, and so already mentioned in some of the preamble of this conference, but the AI helps turbocharge the spread of disinformation. That's a very real concern. And also biases. And, there's significant risk to members of underrepresented groups if we don't think carefully about how to manage and deploy AI-based systems. So those 10 questions are meant to be, like I said, standing questions, things that could be re-examined every 5 years by study panels. And we'll see if that's what happens with the 2026 report. There were two more. And then there's a couple of deeper dives. There's 11 and 12. So the 11th question was, how has AI impacted socioeconomic relationships? This is actually, I think, a very important one, is that, there's a lot of press about robots stealing our jobs. I just talked about this a little bit. It is a possibility that there's, some jobs will go away, but I think, more jobs will be transformed. And it is sort of important that in the data, if you look at the data so far to date, rises in inequality and unemployment don't really appear to be due to the spread of AI technology. There are rises in inequality and unemployment, but it's not due to the penetration of AI technologies yet. Now that may still happen, but that's analyzed in the report. And then finally, does it appear that building in how we think works as an engineering strategy in the long run? In other words, should we sort of put our own intuitions about how intelligence works into the systems, as has been traditionally done in artificial intelligence over the past 70 years or so, or should we let everything emerge and just build an architecture and then have it learn entirely from data? At first, everybody was doing the build it in approach. Most recently, it's been, the pendulum has swung to learning systems as being most influential in the don't build in anything and try to let everything be learned by the AI systems. But the study panel thought that we're seeing the beginning of the end of this trend and a move towards more hybrid designs where there's some learning, but also some structure built in based on our own intuitions. And that sort of, sometimes goes by the name of neurosymbolic approaches to artificial intelligence that merges symbolic AI and neural network based AI, and some people also bringing in sort of the sort of temporally intermediate paradigm of statistical reasoning as well. So those were the 12 standing questions. The study panel also did a deep dive on two particular questions that were based on some workshops that happened between the two study panels. The first one was, how are AI-driven predictions made in high-stakes public contexts? And what are the social, organizational, and practical considerations that policymakers need to consider in their implementation and governance? And so the analysis here was that it's important to design AI solutions to real world problems by working closely with the stakeholders. So don't just build a system that can decide who should be getting that kidney transplant or who should be let out on parole and then throw it over the fence to the stakeholders and have them use it, but involve the stakeholders in the design right from the beginning. And then also the second bullet I think is important. If a problem is complex enough that we need AI technologies to help solve it, then it's also complex enough, at least for now, that AI alone can't solve it. And so, that's again, this motivating people and AI systems working together. And then finally, a very interesting and tricky topic. What are the most pressing challenges and significant opportunities in the use of AI to provide physical and emotional care to people in need? And the conclusions here was that caregiving is an intimate and human act. There is a lot of need for automated support, for help to caregivers, for help to nurses who are in many cases overworked. help to people who don't have access to maybe the personalized healthcare or one-to-one healthcare. But replacing human care relationships could undermine our humanity in tangible ways, and this is a very tricky issue. And so, again, if you want to dive into that, I encourage you to take a look at the study panel report. So the last aspect, and one of the ones that for me personally was one of the most interesting, and I think hopefully will continue from time over time, is that the 2021 group, the study panel, went back and looked at the 2016 report and annotated it and took a look at, basically there's on the web, the AI 100 website, you can read an annotated version of the 2016 report with comments from the 2021 study panel saying, we agree with this, or that was a little bit over optimistic in retrospect, or here's how things have changed in the past 5 years. And, I'll be very interested to see how the 2026 study panel reacts to both of the previous ones, and how this sort of continues through time. And I think so. It's actually very fascinating to look at the changing perspective, some of which may be because it's a slightly different group of people, but also 5 years into the future. And so there's pop-ups if you read the annotated version, anything underlined in blue, that you can sort of see things like this one that says the 2021 group saying we remain similarly optimistic, however, and then they talk about what's changed. So we have I'm about to open it up for questions. The conclusions, the summary here is that AI has made remarkable progress. In some sense, it's in its infancy, but it's also been around and growing, and over the past 70 years, there have been leaps forwards in language and image processing tasks in the past decade, and applications in healthcare and self-driving cars that are starting to have impact. But it's still far short of the field's founding aspirations, which is to create, fully capable human level intelligence. And we're seeing human level intelligence in specific areas, in specific tasks, but it's still there's still many things in which humans are better than computers at. There's a conclusion that we're at sort of an inflection point. I think that we all feel that right now, because of the widespread applicability of the large language models. That automating, we need to consider both the downsides and the benefits, but be realistic and grounded about this. So, automating decisions carries risks. People can be misled, discriminated against, physically harmed by irresponsible or even malicious uses of AI systems. Historical data can exacerbate biases. Social sciences need to be part of this broader AI conversation, and ongoing engagement is essential. The governments need to move quicker than governments tend to work. The pace of policymaking tends to be much slower than the pace of the current developments in artificial intelligence, and that's a real problem. And we also need to keep people informed, and that's part of the missions of the universities to support broad education. And also, I think it's at the point where AI literacy needs to start in K through 12. And then the AI research community needs to learn and to share findings in actionable ways, to avoid the hype, to incorporate AI into community-wide systems and try to help empower, but not devalue people. So again, you can, it's very easy to search for, just AI 100, you'll get it. This is the link to the 2021 report. And you can also find the 2016 report there. So with that, I will, I'll stop sharing for now. I can always come back to some slides if there are questions, but just so you can see me and I can see you a little better, I think. I guess if you turn on, right now the camera in the room doesn't seem to be turned on, but if you turn it on, I'll be happy to take any questions that you might have. Thanks for your attention.
AI models seem to be able to learn and improve much faster than humans could. Due to the asymmetry in memory and other capabilities, what can we humans do if we want to work effectively with AI models in the near future?
Oh, so that's really interesting. So do AI models learn more quickly than people do? Actually, my sense is quite the opposite, right? I mean, to get to a human level chess playing agent or Go playing agent, AI systems need much, much, much more experience than people do, right? It takes time for, maybe less time, but it takes a lot more experience, a lot more data. I think one of the pressing challenges in AI right now, and in machine learning especially, is to make learning more sample efficient, learning from less data. That's something that, you can teach a kid to play checkers, and after a few games, they improve. You have to show millions of games to a computer for it to improve. But, if you're talking about wall clock time, yes, these systems are improving. And I think that's why we need to, sort of be developing them and deploying them in consultation with stakeholders and with the people who will use them. Think about user interfaces, think about, the implications, what happens if they get in the hands of not only people who are using them for positive purposes, but also for potential nefarious purposes. And so I think, I think just raising awareness is step one. That that these are powerful systems, and that we need to think carefully about how they will be used. So I'm not sure if that fully answers the question, but hopefully it at least touches on it a little bit.
Many people have started to use, kind of like ChatGPT and something like that. And it seems to me that many humans use these type of machines because they are not proficient in the area of their questions. And it turns out to be some issue because the answers they get, look often right. Mm-hmm. But if you actually know about the topic, then you often figure out that parts of it are completely wrong. And how can we give humans who use this tool assurances that the answers are right, maybe not complete, but are correct?
That's a fantastic question. I think, one of the things people are realizing is that large language models hallucinate, right? That's the sort of the concept here, that they are, and this is not surprising. The way they're trained is to create plausible output that would be indistinguishable from what a person might say. And so in some sense, their whole objective is to be confident, to emit confident responses that sound plausible. Which is, we all know, probably we all know people who do this, right? Who can confidently say things that are not necessarily true. As people, we learn to try to read that in other people, right? We try to, and there's, concepts of reputation and concepts of expertise. And I think this is part of the need for grounding, for educating people about what these systems can do. They are not authoritative, truth-telling machines. And, I don't think they're not going to be. There's research on trying to figure out how can they more accurately ground their confidence levels. And I think that's important to pursue. But we also need to educate people to not expect, to be able to read them as for what they are, which is, confident emitters of plausible but not necessarily true information. We have to I think that's as much of an education aspect or education goal as it is a technology goal. But I and others are doing research on how can we connect these. For instance, I think it's fascinating. I'm just about to put out a white paper, but on using connecting these systems to other systems that are good at telling the truth, right? So you shouldn't go to a large language model and ask it for the solution to an arithmetic problem, right? If that arithmetic problem happens to appear in this database, if you ask it what's 5 plus 3, it will tell you 8 because that appears all over the internet. But if you take two large numbers and ask them to multiply them together, it will give you an answer that is just a random string of bits or of digits. If it's not in the database, it doesn't actually know how to do math. But we shouldn't go to a large language model to do math. We should go to a calculator. And in some sense, the large language model itself should go to a calculator if you ask it a math problem or a word problem that incorporates some math. And so I think there's some fascinating research in connecting these language models which are trained on how to say things with other systems that are good at figuring out what to say. Because that's not, these aren't good at these systems are not trained to figure out how to tell the truth. They're just trained on how to say things fluently that will look like the truth. And so, that's just the fact. That's what they are. And people need to understand that.
Dr. Stone, can you hear me?
Yes.
So I wanted to point out or maybe ask you about two inconsistencies in the report and something you mentioned. So on the 11th question, you mentioned AI hasn't added to social inequality. And later you said that recidivism predictions have always consistently predicted that certain groups of people are more likely to go back. So do you think that's
okay?
That's not social inequality?
So to clarify that, I think the conclusion, and again, I wasn't on the study panel, but my understanding, my reading of their statement was that AI systems haven't been the main cause of economic inequality. That it's not it's not the job so far. It's not been a huge driver in the there is very much a growing inequality in wealth between the haves and the have-nots, but the conclusion here among the economists was that that's been mainly due to other technologies, not AI technologies so far. But not, I think social inequality. I think there have been studies that misusing these systems can lead to social inequalities. Again, how widespread that is still I think we want to try to nip that in the bud as much as possible.
Thank you for clarifying that. The other thing is this is about the letter. In air quotes, the letter. So one of the risks mentioned in the letter is existential risk to humanity, and the report from AI 100 suggests that that's not an immediate concern. So I'm wondering how those two, how do you bring those together?
So I'm very much in the of the belief that and I think the rhetoric in the letter did sort of raise some of those questions. It asked sort of rhetorical questions like is there a risk to humanity? If you read the text of what's actually being called for, it's not about that. It's not calling for a stop of development. It's calling for a pause of something very, very specific. And the letter does end with a statement that they thought that again, I didn't write it, but I did identify with the last statement in the letter, which was that humanity can flourish with artificial intelligence if done right. And so I'm much more on the side of these reports. I've written one of the reports. I've commissioned one of the reports that existential threats is not a near-term concern. And that's not where I think we should be focusing our energy. I was very much on the fence about whether to sign on to the letter, and if there had been more, if it had been really focused on that existential aspects, then I definitely would have not done so. But I think the more important are these the realistic sort of social, political, economic, legal, and policymaking concerns, and that's where I really think there's urgent need for us to accelerate advances in artificial intelligence to be able to deal with the technological progress. And again, it's sort of like I think if there were a way to wave a magic wand and give us some time to understand the uses of GPT-4 before the development of GPT-5 got started, that would be fantastic. I don't think that's realistic because there's not very many incentives for companies to stop. There's no way to verify it. So I think really the realistic impact of the quote the letter is going to be to raise awareness and to hopefully accelerate the called for studies on implications and on policy. And that was my hope. But I would say if you want to sort of caricature these reports as saying focusing more on the near-term concerns and caricature the letter as being more long-term focused, then I would much more align with these reports and what we write about in detail in the 100-year study.
So let's thank Peter for an excellent presentation.
Thank you very much for inviting me.